All right, so we're doing a Chapter 6 review, and the first thing we talked about in Chapter 6 was factoring of monomials. And all you were looking for were two things that multiplied together, two terms, that you got this. So we talked about maybe it's 12 times a squared b squared. Maybe it's 3 times a squared and 4 times b squared. So as long as the two multiplied together and gave you this, then you had the factor. And it says find 3. So let me do 6ab and 2ab. Over here, 3m to the third, 2m squared. 3 times 2 is 6. 3m's and 2m's makes 5m's. Could be 6m times m to the fourth. 6 and 5m's. You could just do 6 times m to the fifth. So that's all we really talked about in section 1. Now the rest of the chapter, we had two things to do. One was factor, and one was using factoring. So let's start with reminding us how to factor. Step 1, anything we can take out. Well, yeah. They all have one x at least, 1, 2, and 3. So I'm going to fill it in here, x to the first power times x squared minus x times, I need 18, and I need two x's, so I need one more, and plus x times 81. So if I take that x out, I'm left with x squared minus 18x plus 81. So now it's got three terms. We know that this is going to start off with x and probably look like this. There is a negative, so we got all these worries. So x squared negative, or pardon me, positive 81. But since this is negative, I know it's going to be a negative times a negative. So I need something that multiplies together and gives me 81. But when I add it, I get negative 18. How about negative 9 and negative 9? So negative 9, x, and negative 9. So this is negative 9x and negative 9x. They're the same, so you add them together and I get negative 18. So I get x minus 9, or x times x minus 9 squared. Your book will use both forms. I will accept either one to be correct. So you should have your steps to factoring. First, we see what we can take out of all of them. And it looks like I can take at least a 3 out of all of them. And there's at least 2 m's and at least 2 n's. So let's take 3, and we said 2 m's, 2 n's. 3 times 4 is 12. I need a total of 4 m's. I only have 2. Let's get 2 more. I need a total of 4 n's, and I need 2 more. Plus 3 times, I need 3 m's, we need one more, or excuse me, 3 n squared. So we got a 3. M, okay, because there's enough n's. And then here, 3m squared, n squared, and we have 2 times that. So if we pull this apart, we take out that 3m squared, n squared. I'm left with 4m squared, n squared, plus m plus 2. All right, so first, what can I take out of both? 5 times 1, 5 times 4, y to the 6th. Take out your 5, and you're left to 1 minus, 4y to the 6th. Okay, now this is a difference of 2 squares. This is a 1 squared, this is a 2 squared, and this is 6 to the 3rd power squared. So I know box, and again, you may use in reverse FOIL, but you got to understand it. And if you want to, you can always talk to me about that. All right, so in the first box, we know that 5 is done, so I'm just going to put the 5 up here for now. The 1 goes here, and the negative 4y to the 6 goes here. This is a 1 times a 1. Now, we're looking at a negative, so I'm looking at maybe negative 2y to the 3rd and positive 2y to the 3rd. Let's see if that works. And then here's a 1, and here's a negative 2y to the 3rd. I get 2y to the third here, and negative 2y to the third here, and that gives me the 0. So I now have 5 times 1 plus 2y to the third and 1 minus 2y to the third. I check to see if I can factor it anymore. This is not a difference, so I know I'm good to go. This is a difference. 1's a square, 2's not, and y to the third is not. So I am done with that problem. We start with what can we take out of both? And initially you probably don't see it, but what you can take out of both is 4y's. So this is y to the fourth times 100, and then you need 2 more y's, minus y to the fourth times 49. So set that y to the fourth out on the side, and you're left with 100y squared minus 49, which is a difference of 2 squares. Now, if you've caught how to do difference of 2 squares without making a box, you can stop making the box. If you haven't caught it and you want me to show you, just come up and ask. First box, 100y squared. Last box, negative 49. Well, you know what? I'm going to try 7 and negative 7. And here, 10y and 10y. It's the difference of 2 squares, so I'm probably looking at some stuff about squares, 10y and negative 7. And so in this box, I get 70y. I get negative 70y, and when I subtract those two, I get the 0. So now I'm looking at y to the fourth first, and then 10y plus 7, 10y minus 7. Is there anything we can take out of all three? Not that I see. So we know we have 3 terms. We look for a box. All right, 9a to the 8th power, 25b squared. Noticing there's a negative here, so whatever this is multiplied together has to be a negative times a negative to make it work. So I'm going to try 3a to the 4th, because I know 3 times 3 is 9, and a to the 4th times a to the 4th gives me a to the 8th. And I look here and I see, ooh, there's an a to the 4th, probably on the right track. B, and I'm going to try 5. Let's see what happens. So this would be 5b. Let's see, this one would be 3a to the 4th. This would be 3a to the 4th. And this would be negative 5b. All right, so, oh, I messed up. This is a negative 5b. All right, so now inside this box, negative 15a to the 4th b. Inside this box, negative 15a to the 4th b. We usually alphabetize them. And when I add those two together, they're both negative. I get negative 30. So I know I'm on the right track. 3a to the 4th minus 5b. 3a to the 4th minus 5b. And I've checked it. They're not differences of 2 squares because I can't make 5 or b a square or 3. So I'm good right there. What can I take out of all 3? 4. 4 times x squared plus 4 times 10x plus 4 times 25. And we're going to take that 4 out, and we get x squared plus 10x plus 25. Hopefully you're starting to see patterns so that when you look at it, it comes to you really quickly. I look at it and I say, up, I get 3 terms. That means I got to start drawing my box. Whoops. All right. 4 is done. It's something times something if it all works out. So here is x squared and 25. I need a 10 in the middle. Multiplies to give me 25, adds to give me 10. Well, that's 5 and 5. X and x. So here we go. This is a 5. This is an x. This and this are the same. Boom. This and this are the same. And I get 5x and 5x, which gives me the 10x I was looking for. So x plus 5. There are no differences, so I'm done. I know I'm doing good. What do they have in common? They all have at least one x. So this is x times x to the fourth, x times, well, I need a 6, x squared, plus x times 5. So take that x out, and I get x to the fourth minus 6x squared plus the 5. Now I'm ready. I look at it and go, there's 3 terms. 3 terms means I box it. And take the 15 seconds to draw the box out completely first. X to the fourth and 5. This is probably because there's an x squared in the middle, x squared and x squared. And look, it's negative 6. So this is going to be a negative times a negative. So negative 5 and negative 1 gives me a positive 5. And negative 5 and negative 1 added together gives me negative 6. So I think I'm on the right track. X squared. So x squared, negative 5. Okay, so now x squared minus 1, oops, let's make sure it works. Minus x squared minus 5x squared does equal minus 6. So this is right, and this is right. Completely factoring, well, this is a difference, and here's a square. 1 is 1 squared, so we have the difference of 2 squares. This is not a difference. It's done. This is going to change. So we're going to leave x squared plus 5 there, and now we're going to put it into a box. I know that it's a lot of work, but not too difficult. So here goes my x squared and my minus 1. Well, I know this is x times x. I've done this enough now. Negative 1 and 1. 1, x, x, negative 1. And so in here I get x, negative x, which gives me that 0 in the middle. So I have x plus a 1, x minus a 1. That's the only difference. It's not squares. So that's my answer.